Hi, I'm Cornus van der Lucht. Welcome to session 4 of our Resource Revolution Trainer. In the previous session, you learned about the principles of the Resource Revolution. In this session, we're going to look at the building blocks of turning your enterprise into the Resource Revolution enterprise. The building blocks that we will be looking at in session 4 of our online training are building blocks for your Resource Revolution enterprise as defined by the authors Heck and Rogers in their book on the Resource Revolution. You will find a list of these building blocks on slide 3, starting with interchangeable parts. By the end of this session, you should have a better idea of what they involve and which of these building blocks are more specifically applicable to your business. Starting off with interchangeable parts. The future may very well look like Legoland. And in that Legoland, conventional building and construction may find itself in the role of a non-hero. Building and construction has often been referred to as the third industry, being responsible for well over a third of global resource use and close to 40% of solid waste. Think of the opportunities that interchangeable parts could bring to the building and construction industry. You can look at the example of recognized innovators in the use of interchangeable parts. Companies such as Interface from the USA, the production of tiles, replaceable tiles. Companies such as IKEA from Scandinavia, Sweden. And also Broad Sustainable Building from China with its production of modular blocks made of concrete or steel to radically, for example, speed up the time frames within which new buildings and constructions can be put up. Now we move on to the next slide and we look at an innovative example coming from Canada, the company DIRT. The name stands for Doing It Right This Time. Management of this company sat down with colleagues and they took all the components and processes, the products and processes of their enterprise and broke them down to the most basic parts. And they tried to reconfigure how can they reconnect all of this in a functional way and with a holistic perspective. This company manufactures building interiors. And they use the wall as an organizing principle. So they organize and manufacture wall panels that come in different shapes and sizes. And with these walls, interiors can come, for example, electrical fittings cut to the exact sizes required by the client. Between these wall panels, they make use of special connectors which are parametric, which means they are standardized in a way that you can easily make the connections between different panels, even if you change the materials they are made of, even if you change their sizes, even if you change their colors. So radical productivity opportunities accomplished by this company DIRT, with some lessons for interior designs that were applied in major office buildings and hospitals, etc. The next building block we're looking at is that of systems integration. Now, resource-intensive industries are said to be particularly bad at systems integration, believe it or not. An example is the old power industry, the power grid, which is said to be technologically where the telephone industry found itself in the 1940s. The power grid, for example, still relies on customer complaints to send out maintenance teams and to go and do repairs in a reactive manner wherever repairs are required. Similar inefficiencies can be found, for example, in irrigation in agriculture. You can look at opportunities related to systems integration in various industries, also heavy industries and infrastructure, for example, transport. Radical resource productivity opportunities that can be introduced through, for example, lighter rolling stock, better control of flows, and better load factor management. In the shipping industry, our slide highlights there the example of the company Vicon, innovations they introduced in that industry, and key here again is not to think of different components of the shipping industry in isolation, but to look at the ship, its routing network, and the harbor as a holistic system. Also on the theme of systems integration, take the telecommunications industry. The telecommunications industry has seen radical milestone innovations historically. For example, the replacement of switches with automated relays after the Second World War, and the introduction of SDN routers by the company Cisco in the 1980s, which paved the way for the introduction of mobile phones and the internet. And then in more recent times, another shock to the industry introduced by the company Skype. And in this case, not through a hard technology, but a soft technology, through its innovative alternative business model, a free business model, in which a majority does not have to pay and benefit from a minority who is willing to make a payment for an additional service. Now you can take some inspiration from other systems integration innovators such as Amazon, Twitter, and Spotify. The third building block in our resource revolution for your enterprise is that of embedded software. We spoke of that example from Canada, the company Dirt, where management sat down with employees and broke products and processes down to their most basic parts. Software plays a key part when you now move on to look at the reconfiguration of how these different parts could fit together in a more efficient manner, enabling that radical resource efficiency improvement that Dirt has been able to accomplish through its production of building interiors. Embedded software, importantly, requires collaboration between different disciplines, and this highlights a key role now to play by the software engineering discipline, collaborating with established disciplines such as mechanical engineering. This includes taking on possibilities associated with big data, as well as intelligent use of intuitive interfaces, the type of interfaces customers and consumers have become used to thanks to the types of products introduced by Apple under the leadership of Steve Jobs. The car manufacturer Tesla is challenging traditional manufacturing by working with Panasonic and relying on innovations from consumer electronics to improve battery efficiency. Intelligent use of software also includes improvements in controls, enabling feedback loops in equipment so that a piece of equipment basically monitors its own performance continuously and learns from its own performance, enabling itself to continuously improve. An example comes from the company General Electric. Its jet engines are fitted with sensors that monitor performance, and before a plane even lands, it radio signals to maintenance on the ground whatever type of repairs or improvements need to be done, so that maintenance on the ground already knows what needs to get done even before the plane has landed. The area of embedded software also highlights the arrival of a new type of system or business model, which is that of the so-called product as service model. You may be familiar with discussions over the last 2 decades on what can be accomplished through the introduction of so-called product service systems. But embedded software today brings to us the possibility of introducing the product as a service model. And key here is the realization by your enterprise that a product is not a goal in itself, but the product is really a vehicle to introducing more and improved services to customers or clients of whatever type. This is a model described by Michael Porter and his colleagues in this recent article from the Harvard Business Review. They highlight the fact that products are becoming complex systems with embedded software and more offered thanks to the cloud. They, among others, quote the CEO of General Electric, who said that every industrial company today should really become a software company. Another example they cite is the company John Deere, which traditionally used to manufacture different versions of the same engine, different versions with different levels of horsepower. Today they simply manufacture one standard engine, and different levels of horsepower is simply set through the application of software. Again, software embedded as a key component within that piece of equipment. The next building block, number 4, is that of biological methods and nanotechnology. Important the lessons we can learn from nature. For example, the fact that natural processes are typically reversible, and this means that materials can be, in principle, recovered and reused. Look at the area of biomimicry and take lessons from what we can learn from nature. One example is the German company ISPO. Through its study of the structure of the lotus flower, it developed a new type of paint that rejects dirt. And if that is not interesting enough, look at what could be done in the field of agriculture. You have today companies doing research to explore alternatives to chicken and beef, highly resource-intensive products, among others, highly water-intensive red meat. Trying to develop alternatives to beef and meat that look and taste very similar and potentially have higher nutritional value. In Israel, the company Kaima is looking at alternative grains, rice and wheats, seeking to help us to move away from the dominance of corn, because we need diversity in our diets and the industries behind all of that. This company is examining those alternative versions of, for example, wheats, alternatives that will be more efficient in its usage of water, land, energy, and at the same time products that have higher nutritional value. Looking at new innovations of nanotechnology, they bring high potential for application in areas such as environmental remediation and water filtration, as well as energy. Material sciences are going down to the nanometer scale and introducing radical innovations in the area of surface properties and absorption characteristics. The type of innovations also examined here at IMPA in Switzerland. The final building block for your resource revolution enterprise that we're looking at is that of network effects. Network effects highlight the idea that every additional phone and computer added to the network brings value to the network and enables further growth of the network. This brings about the so-called Internet of Things, in which increasingly these pieces of equipment can communicate between themselves. The company Ericsson, for example, estimates that by the end of this decade, there will be some 50 million devices in the world. And over 80% of these devices will be communicating to each other ongoing without human intervention. What kind of devices are we talking about? In addition to computer technology and software usage, these include devices such as sensors and cameras. We spoke earlier of the example of General Electric and the use of sensors to improve the functioning of technologies in the jet engine and sending signals to maintenance for repairs. The International Resource Panel, in its Cities Decoupling Report, also took on the topic of network effects when it highlighted the important role of intermediaries in enabling decoupling at the level of cities. It highlighted that these intermediaries are both humans as well as technologies, and the fact that on the technology front, these intermediaries include technology manufacturers and service providers, companies such as Cisco, Siemens, and General Electric that are currently shaping the city market environment also to roll out more efficient products. The building block number 6 that we're looking at is step-by-step engagement of customer segments. What is at stake here is what has been described by the author Jeff Moore as the chasm. That is the gap in moving from the take-up of a new technology by early adopters to take-up by the mass market. So the challenge that you face in crossing that gap, the chasm between the early adopters and the mass market take-up. This also involves new approaches to looking at backward compatibility. And it's clear today, as we discuss the resource revolution, is that backward compatibility is not only about hardware technologies, for example, the ability of a new kind of plug to fit into an old socket. Backward compatibility is also about soft technologies and is also about consumer psychology and behavior and social norms that we apply in the business community or that we find in society. We spoke earlier about the need to make it easy and attractive for your consumers and your customers to take up that new resource-efficient technology. Now, an innovative example can be found from the company Calstar, making use of fly ash, a byproduct from coal mining and coal production. Making use of fly ash, they produce cement, a product that looks like and behaves like cement. And considering the initial questions that customers may have had about this alternative to cement, they introduced its use in an area that is fairly conventional, namely bricks and pavers, an area in which they also didn't have to go through a complicated certification or registration process with regulators. So they followed this approach to step-by-step engage clients and prove to them that this alternative products behaves the same and can do just as well as conventional cement. Now, a challenge for the heavy industries, the resource-intensive industries, in engaging consumers step by step is two features if we look at the nature of these industries. First of all, the fact that you're dealing with longer product cycles. Compare the difference in product cycle between a mobile phone, which a consumer may decide to replace every 12 months, versus a solar technology, which will take many more years to replace. Heavy industries are not known to have extensive research and development budgets. It's, for example, said that the construction industry on average has a research and development budget that is lower than that found in the dark food industry. So this is one challenge for heavy industries in considering their lengthier product cycles. A second challenge for them is that they traditionally are not in the habit of connecting with the psychology of the consumer. Now on the next slide for you to consider, we have a graphic that illustrates the time it took for consumers to take up new technologies in the US market. The pace of new technology adoption in the USA historically. New products in the domain of ICT, mobile phones, computer technologies, etc. have been taken up by the mass market at a much faster pace, as is evident from this graphic. The challenge, of course, would be for the heavier industries with their longer product cycles to accomplish the crossing of this chasm at a greater pace compared to what has been the case in the past. But do not underestimate the possibility for some surprising results, particularly through the combined usage of the hard with the soft technologies and smart usage of embedded software. Take, for example, what could be accomplished in the domain of intermodal transport through clever use of embedded software and systems integration. So we've gone through a list of building blocks of turning your enterprise into the resource revolution enterprise. As we conclude this session, let me challenge you to reflect and discuss with your colleagues which of these building blocks apply most to your business. This is a question we would like you to discuss internally inside your company, one of a number of questions that you will find in the additional reading materials to this session. And we would also challenge you to reflect on what role software plays in the making of systems integration in your enterprise and connecting your products and services to its surrounding business ecosystem. So there is plenty of food for thought to find in the exercises that you'll find at the end of session 4. And we look forward to seeing you again in the next session 5th of this online training package.